In the incredibly complex universe that lives between your ears, there are certain stars that get all the attention. We think of them as the masters of thought and memory. But what if the real story, the secret to how our brain actually works and stays healthy, lies with an invisible, hardworking support crew?
So let me ask you a question, straight up. What do you think is the single most important cell in your brain? Just take a second and think about it. What's your answer?
I'm willing to bet you said the neuron. And look, if you did, you're in good company. For well over a century, neurons have been the undisputed celebrities of the nervous system. They're the flashy communicators, the ones sending all those electrical signals that make everything happen.
But today, we are going to pull back the curtain. We'll start with that star player, sure, but then we're going to meet the brain's real unsung heroes. We'll find out why they're so much more than just glue, how they literally fuel the entire network, and what happens when that crucial support system breaks down. And finally, we'll look at what this all means for the future of brain science.
Okay, first things first. Let's give the star its due. We're starting with the cell that usually gets all the credit, the neuron, the supposed master of communication.
So what do neurons do? Well, they're the main players in the nervous system. They're what we call excitable cells, which means they fire off these amazing little electrical signals called action potentials. They use these special connections, known as synapses, to talk to each other, and in doing so, they form these massive, intricate circuits that create our thoughts, our memories, our emotions. They are, without a doubt, absolutely essential.
But here's the twist. They don't work alone. Not even close. It is time to meet the brain's real unsung heroes, the glial cells.
You can see how we got this so wrong for so long just by looking at their name. Glia actually comes from the Greek word for glue. Yep. For decades, scientists literally thought these cells were just passive filler, brain putty holding all the important neurons in place. It turns out that could not be further from the truth.
First up, we've got the astrocytes. Think of them as the brain's diligent caretakers. These amazing star-shaped cells are constantly working in the background. They manage the chemical environment, they feed neurons the nutrients they need, and, this is a big one, they help form the blood-brain barrier. That's the super selective shield that decides what gets from your blood into your brain tissue.
Next, meet the oligodendrocytes. These guys are the brain's master electricians. Their whole job is to wrap the long wire-like axons of neurons in a fatty substance called myelin. This myelin sheath is like the plastic insulation on an electrical cord, and it allows nerve signals to travel up to 100 times faster. 100 times!
And rounding out our crew, we have the microglia. These are the brain's personal bodyguards. They're the resident immune cells, and they are constantly patrolling the environment, looking for any signs of trouble. If they spot an injury, an infection, or even just old cellular junk that needs cleaning up, they spring into action to handle the threat and protect the neurons.
So, I think we can all agree these cells do a lot more than just stick things together. This isn't just a support crew. It's an active, dynamic, and absolutely essential partnership.
You can really see the division of labor when you put them side by side. Neurons are built for one thing: speed and long-distance communication, with those specialized axons and dendrites. Glial cells, totally different. They don't send those fast signals. Instead, their job is to support, protect, and manage the entire environment so that the neurons can do their job properly. It's a perfect partnership.
And this shift in understanding was so profound that back in 2005, a couple of neuroscientists, Volterra and Mendeletti, wrote that the revolution continues. Astrocytes went from being seen as simple brain glue to active communication elements, and that completely changed how we view the brain.
So how does this partnership actually work? What does it look like day to day? Let's zoom in on one of the most critical functions there is, fueling the brain's incredibly complex power grid.
Okay, so your brain is an energy hawk, and its absolute favorite food is glucose. But here's the thing. A neuron can't just reach out and grab glucose from the bloodstream. First, the glucose has to cross that blood-brain barrier using special doorways called GLUT1 transporters. Then, and this is the crucial part, it's actually an astrocyte that grabs the glucose first. That astrocyte processes the fuel and then hands it off to the neuron, which finally takes it in, using its own special set of transporters.
Just stop and think about what that really means. Without the astrocyte playing the role of this indispensable middleman, this gatekeeper, the neuron would literally starve. The support cell is the essential link in the brain's entire energy supply chain.
Which, of course, brings us to a really critical question. What happens when this partnership breaks down? What happens when communication fails? Well, this is where we see the profound and often devastating link between glial cells and disease.
We can now draw direct lines from failures in these support cells to specific disorders. For example, when oligodendrocytes can't maintain that myelin insulation, we see diseases like multiple sclerosis. When the astrocyte's energy support system breaks down, it's a major factor in the damage from stroke and in Alzheimer's disease. And when those microglia bodyguards go from protectors to aggressors and cause chronic inflammation, that's a key feature in both Alzheimer's and Parkinson's.
Let's just stick with Alzheimer's for a second. One of the leading ideas right now, what's called the neuroenergetic hypothesis, basically says the disease could start with an energy crisis in the brain. We see in patients that glucose uptake is way down. We see that those critical transporter doorways, both GLUT1 and GLUT3, are getting turned down. All of this points to a fundamental failure in the brain's power grid, a failure of that neuron-glia partnership being a key reason why brain cells die and cognition declines.
And all of this discovery, all of this new knowledge, it brings us to the brain's next great frontier. It is forcing us as a whole to completely rethink the fundamentals of neuroscience.
So, if you take one thing away from all this, let it be this. The brain isn't just a network of neurons. It's a society, a complex, deeply collaborative society of all these different cells, each with a vital role to play. The stars of the show simply cannot perform without their entire crew.
And that leaves us with one last provocative thought to chew on. For decades, all our efforts to cure brain disease have focused on fixing the neurons. But if the whole system depends on their support crew, maybe the key isn't just fixing the stars, but making sure their entire team is healthy and functioning properly. What do you think?